Hello everyone, myself Dipanshu Mukherjee, lead machine learning analyst at Dataspace Security Private Limited. Today we will be discussing about the image classification between a dog and a cat. That means how you can classify an image between a cat and a dog. So there will be some features, and this project is mainly for the deep learning. Okay, we will be using the deep learning things. So first we will just look into our deep learning concept, that what is the deep learning and how you can recognize an image through convolution neural network. Okay, so let me share my screen, that the concept of the deep learning. Okay, I'm sharing my screen. Okay, I think it is visible properly. Okay, so we'll be discussing about the deep learning. Okay, deep learning. So in the concept of deep learning, there is a thing that is called the neuron. In the human being, in the human body, the main thing will be the neurons. Someone touches your hand, it will just, if this is very hardable, then it will be very much it will give us a noise from our some part. Okay, so this how this can be occurred, this is the concept of the neuron occurs. Okay, so you can see there there'll be two neurons, and they will be connected each other through some transformer. This is called the axon, this is called the dendron. Okay, now one dendron is the last position of the another axon. Okay, so that's how a neuron be created. This is the called of the this is we can call in the human body. But for machine, what will be the concept? You can see this is called the neurons for machine. There will be some input concept, there will be some hidden layers, there will be some output layers. Okay, we'll be discussing one by one, and you can see each and every neuron. This round figure is called the neuron, and you can see this each and every neuron will be connected to each other. Each and every neuron, you can see this one neuron is connected to each and every neuron. Each and every neuron, you can see here, each and every neuron. Okay, so that is how a neuron can be built in machine learning, or rather than a deep learning. Now there will be a process that is called the activation function. So before that, you can see this is called the input layers. This is called the input layers or the feature layers. Okay, there will be some features will be there, and this is called the input layers. This is called the output layers of the neuron. Now, between this input and output layers, there will be many layers. This is called the hidden layers. Okay, this is called the hidden layers. You can see. And each and every hidden layer is connected to input layers as well as output layers. So that is how a neuron can be built. And we can use, there will be no hard and fast rule that we can use one hidden layer or two hidden layers. There will be no hard and fast rule. But we will usually use one or maximum two neurons, because if we can use more than two, more than three neurons, it will be very much complex. So that's why we can use mainly one neurons or maybe maximum to two neurons. First of all, we will just put our features into our input values. This is called input features, and it will get pre-processed through this hidden layers, maybe one, maybe two, anything you can do, and lastly, it will give us an output like this. So that is how a neuron can be built. Next one thing will be the activation function. Before coming to the part of activation function, you can see there will be some. This is called the features x1, x2, and this is the bias, or maybe we can say it as a residual. Now you can see x1, x2. This is the features, and we will give us an weight with x1 and x2 as well as up to xn. This will be the w1 x1, w2 x2, and we will calculate the sum of wi xi. I can be from 1 to n. It can be 1 to n. and we will put a bias or residual into this. We can put a residual into the sum of the part, and it we will calculate the whole thing. This is called the sum. And lastly, after calculating the sum, we will give an activation function, that is the alpha. We will give an activation function. You can see this is the activation function. We can give an activation function to convert this whole thing between 1 or 0, maybe 1, maybe 0, anything it can be. So the function of the activation function is the to convert the whole thing, the whole sum between 1 to 0, and it will give us a fruitful output, that is y. And after that we know about that we will calculate the error. That means this is called the predicted y, and we know about the actual y. So this is the error, y hat minus y. This is the error. Now you can see y equal to alpha of z. That means this is the sum, and z will be the summation of wi xi plus bias, and alpha is called the activation function. You can see here the whole thing will be this type of thing. So this is the neurons, and after passing through each and every neuron, you can see this is activation function will come into the part. Now there will be many types of activation functions. So what are the types of the activation function? There will be two types. One is the linear activation function, another is the non-linear activation function. So linear activation function means this is quite simple. That is ax plus b, y equal to or fx equal to ax plus c or b, anything, a constant. A will be the intercept and c will be the constant. And for non-linear activation functions, there will be many types of activation functions. That is the sigmoid, ReLU, CANH, softmax, anything it can be. But most of the times we will use the ReLU activation function. Most of the times we will use the ReLU activation function or sigmoid activation function between, because it will simply get converted between 1 to 0. It will be easy for calculation. So that's why we will use most of the time the ReLU or maybe the sigmoid activation function. So you can see in the graph there will be two activation functions. One is the sigmoid function, another is the ReLU function. You can see this is called the sigmoid function, and you can see the concept of the or the formula of the sigmoid function will be 1 by 1 plus e to the power minus z. This is the alpha of z. This is called a sigmoid function. You can see if the value will be greater than 0.5, it will treat it as a 1. Otherwise, it will be treated as a 0. So that's how we can convert the value of sigmoid function. Similarly, for ReLU, the RZ will be maximum 0 to z. That means if it will be greater than 0, it will be that value. Otherwise, it will get the value of 0. So that's how a ReLU can be worked. So this is the activation function. So this is the linear and non-linear activation function. Most of the times we can use the non-linear activation function to our sum to convert the value of 0 to 1. This is the activation function. Now the next thing. So you can see in the picture, you can see this is the one or maybe the bias x1 up to xn, the value, and we will give us an weight w1, w2 up to wn, and we will calculate each and every sum, weighted sum. This is called the weighted sum, and we will pass through the value into an what we'll say into an activation function, and it will give us a fruitful output. Now you can see here in this picture x1 and x2, x1 and x2. You can see this is the w1, this is the w3, and this is the w2 for this and w4 for this. So you can see this is the weight x1 w1, and when it will go into this neuron, you can see this the weight will be calculated as w3. And similarly for x2, the weight can be calculated for w2, and similarly for x2 for this neuron it can be calculated as a w4. And similarly for biasness, it will be b1 or b2 for biasness. You can see this is the constant with the weighted of w0. And after that, this is the hidden layer neutron, and this is the hidden layer neuron. So two neurons will be, and we know that each and every neuron will be connected to each and every neuron. So this is the hidden neuron, this is the input neuron. Now you can see. So we have calculated our hidden layer or hidden neuron. Now we want to give us the output of the neuron. So you can see H11, H12. So there will be two things, H11 and H12. And we will give us another weight to this input layer, to this hidden layer. And for this hidden layer, that is W5 and W6 correspondingly. Now you can see H1 W5 and H12 W6. So two weights will be there. And after passing this weight to a activation function, that is A21, it will be given us the value of WY hat. So this is the predicted value of Y, and also the bias will be there, that is the B3. So bias will be there, so B3. So X1 and X2, these are two input and output will be Y cap. So this is our predicted output. So this is our predicted output. Now you can see, so the first thing will be, you can see, we will go into the input layer and then hidden layer, and then after that it will go into the output layer. So this is called a feed forward neural network or feed forward propagation. Anything we can say. Feed forward neuron or feed forward propagation. So that is how a neuron can be worked. But what about to minimize the error? That is y hat. Suppose the value of y hat will be there. Just a moment. Okay, stay in the call. Okay. Now going to the part. Okay. So you can see the input layer, hidden layer, and output layer. So three layers will be there. Now y predicted will be something, and y will be the actual value. So what about the minimize of the error? So to minimize the error, we can update the error. We can update the weights. So that is how we can check our values, check our actual values to our predicted value. We can correlate our values with our actual values to our predicted value. So how can we do that? This is called the feed forward. Similar concept will be there, that is called the back forward or the back propagation. So how can you simply calculate your weight or update your weight? So you can see x1, x2 up to x trip 3 x's will be there. So it is the input layer, this is the hidden layer, and after that another hidden layer, and lastly we have predicted our values, that is either it will be in the green or in the white. So this is our desired output. Now, when we will give us another thing, that is, it will get updated with the values of weight. You can see, so this weight can be calculated into this weight, and for this weight, it will be calculated for this weight, and lastly, this weight can be calculated for this. So that is how a back propagation happens. So you can see this is the formula: W new equal to W old minus alpha into DE DW. W new will be the new weight for xi value. W old will be our old weight for the xi value. Alpha will be the learning rate, and it can be treated as 0.01, the less thing. And DEDW, that means the derivative of the error with respect to our weight. So that is how an updated weight can be calculated. So what is the concept of the back propagation? You can see. So first we will give an input layer. After that we will go through in hidden layer. Another hidden layer will be there, and lastly there will be an output layer. After that, when we will just go through into output layer, the weight gets updated with the value of this W new value. So this is called the perceptron. So this weight can be checked. This weight also can be checked, and for this input layer, weight can be checked. So that is how weight can be updated. And after that, after updation of the weight, we will go another thing, that is again this feature with the updated weight, with this feature the updated weight, and with this neuron or feature the updated weight, and after that it will give us a fruitful output. If the output, the error will be not minimized at all, optimized not at all, we will get updated, this weights or will be get updated again and again till the value can be, the value of the error can be minimized. So that is how a back propagation can be happen. Back propagation means it will go from output layer to our input layer to get the weights can be updated. So that is how a back propagation can be held. So this is the concept of the back propagation. So we have done about our feed forward neural network and the back propagation, and the whole thing is called as a perceptron. Okay, now this is the concept of the whole neural network. But what about the CNN, actual CNN? You can see when we will just give into a input data of the image, the image can be recognized as a 1 or 0 matrix. So this is the input data. It will give us an matrix because we know that it cannot be recognizable as an image. It will obviously get converted to this 1 or 0 value. So the whole thing will be converted into a matrix that is consist of the 1 or 0 value. So this is the input data. Let's take a kernel. And anything can be happened in the kernel. You can see this is the kernel 101010101. So we will go to this kernel each and every 3 cross 3 value. You can see this is the matrix of 3 cross 3 and this is the matrix of 1, 2, 3, 4, 5. That is the 5 rows and 5 columns will be there. So 5 cross 5. So we will picturize this kernel each and every value, every 3 cross 3 value. You can see. So first of all, you can see this and this and this. So this 3 cross 3 will be there. After that, it will shift it to the next column, that is this 3 cross 3 rows. After calculation, it will go into this 3 cross 3 rows, and after calculation, it will go this 3 cross 3 rows. There will be another empty rows will be there. So what is the calculation? You can see this 3 cross 3, this 3 cross 3 matrices, and this 3 cross 3 matrix will get calculated by some calculation. That means this is the 1 into 1. So you can see 1 into 1 will be 1. 0 into 0 will be 0. Similarly, 0 into 1 will be 0. Similarly for this row, same thing will be happening. So you can see lastly, we will just get summed up all the values, that is 4. It will be getted at 4. You can see this is the 4 value. And similarly for this 3 cross 3 matrix, the value will be gets updated as a 4. So this is the convoluted feature. Okay, this is called the convoluted feature. So that is how a kernel can be worked. And you can see when it will get updated as 3 cross 3 this matrices, it will go into the next row, that is this 3 cross 3 matrices will be there. And similarly, next thing will be this 3 cross 3 matrices for this particular kernel. So that is how we can classify a value to the image. So after convoluted feature, it will go into the fourth value. So it will be, so this is our input feature. So all the features will be calculated as an input feature. So that is how, as we know that machine cannot read any type of textual or image type of data. Obviously, the image can be converted. It will obviously be converted to the values of 0, 1, or like that any type of numerical values. So that is how a convolution neural network can be happening. Okay, let's take an example for the convolution neural network. So suppose there is a value that is called like a 2. There is the image. This is the image, not a value. So this is the image of the 2. So you can see it will get updated each and every value, each and every it will take as a matrix, each and every value. Similarly, this is also the matrix, this is also the matrix. Remember, there is another thing that is called that is the concept of the RGB. That means red, green, and blue. Okay, so this is the part of the red, green, and blue. So you can see, so this is the first matrix, that is the this matrix. A moment, this is the matrices. This is the matrices, and it will mapped into a kernel, that is this kernel. So this is the kernel. Okay, so that is how we can validate our padding each and every matrices with our kernel value. And when it will give us each and every matrices, and we do not take each and every value, so we will give us the maximum value. So that's why this is called a maximum pooling. So this is called a maximum pooling to this each and to this CNN. And after that, this convoluted value n1, you can see this is the 24 into 24 into n1 channel, and this is previously this is the 28 into 20. So this will get updated as 24, and similarly after max pooling, it will get converted to the 12 cross 12. And after validating our padding, you can see this is the value of 8 cross 8. So that is how a matrix can be occurred. And lastly, this is the 4 cross 4. And you can see each and every value can be flattened with this each and every value. So that is how a max pooling can be occurred to the neural network. And you can see this is our features, numerical features, or rather than our input variables. And after the input variables, you can see after the input variables, we will go through this type of neural networks. That is, it can be hidden, not it can be, it obviously be the hidden neuron or the hidden layer. After passing the obviously after passing the any type of activation function, maybe it can be ReLU, maybe it can be anything sigmoid, maybe anything it can be. Okay, so that is how a neural network can be occurred. And after passing through this hidden layer, it will give us an output that it may be 0, it may be 1, it may be 2, it may be 9. So that is how a convolutional neural network, image based neural network, can be happened for what will the CNN or the artificial neural network, anything it can be happen for the convolutional neural network. So this is all called the uh, convoluted maximum feature. So this is the convoluted feature. And obviously there's another thing that when we will just give us an output or give us through what will say give us through a neurons, we obviously add a activation function. Obviously we can add a activation function. Okay. So this is the concept of the CNN or the deep learning thing. There is the concept of the CNN. Now let's dive into our project. That is how you can simply calculate or how you can simply classify an image between this dog and between this cat. So this is our project. So let's dive into the thing. So first of all, let me picturize something. That is, uh, let me check my data. What will be the data? So this is our data set. Okay, so this is our data set. This is called the test data set, and this is the training data set. You can see this is the training data set. So this is the all images of the cat. Okay, all images of the cats. Here you can see 4,000 images will be there. So this is all images of the cats. You can see all images of the cat. And this is the all images of the dogs. You can see all images of the dogs. Maybe something you can see here. There will be another thing that is not only the dog. There will be a human. Also there is the human. So how you can recognize this is the human, this is the dog. So this is the thing. So let's dive another thing that is this is called the training set, and we'll obviously differentiate between training set and test set. You can see the cats and dogs for the test set, and the test set consists of 1,000 items. Okay, 1,000 items will be there for this type of dogs. Now the main thing will be this dog is in the side position, but this dog is in the front position. So how you can how our machine can be recognized as a not the also the side position and also the front position. So this is the thing, and this is obviously this is the proper dog, I mean dog picture. So you can see. So there's a little bit different, difficult to identify the side faces of the dog, but our machine can be helped you. So how you can differentiate how you can classify your values of the dog and the cat. So let's check. And there'll be another thing that is the cat. There is also 1,000 items. So this is our uh, this is our set, and you can see there will be another thing that is the test dog, and we want to check our value the if it is a dog or not after validation of our model. So this is our task. So uh, okay, this is a proper dog. Okay, so we can check. Now let's check that our machine can be identifies the values of this dog or not. Let's check. Okay, so first of all, we have to import our libraries. That is our pandas. Import pandas as PD. Import numpy as np. Import matplotlib.pyplot as pht. And as we know, this CNN can be occurred with the backend of the Keras. So we have to import the value. We have to import the library that is the Keras. So our module will be our keras. So from keras.models, import sequential. From keras.layers, convolution 2D. And from maxpooling 2D, dense and flatten. All the libraries should be extracted. So in the backend of the keras or backend of the keras in the TensorFlow also. So now let's check. So we have imported all the libraries. You can see all the libraries. Now, as we know that there will be another thing that is called the sequential. So we have to give an input layer. So to make the input layer, we have initialized the CNN with an object, that is the classifier equal to sequential. After that, we'll have to add our input value one by one. So you can see classifier dot add convolution 2D 32, 3, 3. So 32 means the 64 divided by 2 will be the 32, and we know that 64 will be our images. And 3 cross 3, that will be our kernel. So 3 cross 3 will be there, and input shape will be 64, 64, 3. So this is our input shape. This is our also an input. And the activation function for this neuron, the ReLU. So we have written activation equal to ReLU. So this is our activation function. Now, after activation function, we'll have to give us our pooling. So our maximum pooling will be there. We have used the maximum pooling, not the. We can also use not only the maximum pooling, we can also use the sum pooling. That means the value, the sum of the all the values. So we can also use the sum pooling. But most of the time we can use the maximum pooling. So max pooling we have used, so that we have written classifier dot add max pooling 2D. Pool size will be 2 comma 2. So there will be 2 cross 2 matrices will be there. So pool size will be 2 comma 2. After that, we'll have to use the second convolutional layer. That means second hidden layer will be there. So classifier dot add. Why we have used the second hidden layer? Because you can see the pictures of the dogs or cats in the side faces also. So there will be some complexity will be there. So to crack the complexity, we have to use the we have to use the hidden layer more. So that's why we have written classifier dot add convolution 2D 32, 3, 3 and activation should be the ReLU. And similarly for this classifier dot add maximum pooling 2D, pool size will be 2 cross 2. That means 2 cross 2 matrices will be there. So you can see this is the convolutional second hidden layer, and we have to use the maximum pooling similar to this hidden layer. Now, after that, we know that we have to give an input. To give an input, we have to use the flatten layer. So that we have written classifier dot add and the flatten function. So classifier dot add flatten function. After that, we have to use the full connection. That means this is called the full connection. You can see in the this all the things will be called as a fully connected layer. So this is called the fully connected layer. So you can see this is the fully connected layer. Okay, so you can see this is called the fully connected layer, fully connected neural network or fully connected layer, because all the things can be happened in one at a time. So that's why this is called the fully connected layer. Now, now you can see, just a moment. Now you can see. Okay, so classifier dot add dense output dimension will be 1 to 8. That means output dimension will be 1 to 8. So what is the output dimension? We know that we have written this all the values of the maximum pooling, second convolution there, but our what will be our input? You can see this our input will be 1 to 8. That means our input will be input pitches will be consist of the 1 to 8, and activation function should be called as a ReLU. We have added the activation function as ReLU. And for classifier.add dense output dimension should be 1. That means first input layer, this is called the first input layer, that is the output dimension 1 to 8, and this is the output dimension of the last thing, that is called the 1. And we have written the activation function as sigmoid function. So this is the sigmoid function we have written. We have written the activation function as the sigmoid function. Now we have to lastly we have to fully connected layer, we have to give the compilation. So that we have written classifier dot compile optimizer will be Adam. So we have to use the optimizer. That means we have to use the values as a optimizing thing. That is, so that's why we have written the Adam value. Loss equal to binary cross entropy. So this is our loss function. And matrix, we have to check the matrix's value, that is matrix equal to accuracy. So you can see this is the output value will be the accuracy. Okay, so this is the thing, we have done all the things about the CNN. But after that we have to uh, fit our images to each and every value. So we have already given our things, that is the CNN value. Now we have to generate, or we have to read our images. So how to read that? So you can see, first of all, we have to use the from keras.preprocessing.image import image data generator, and after that the train set will be our 4000 images. We know about that. So you can see image data generator rescale equal to 1 divided by 255. So why 255? Because we know this 255 is called as a white, and for 0 is called a black. So that's why 255 we have written. So we know about the grayscale thing, grayscale images, that is 1 2, that is 255. Shear range, that means point 2, and zoom range will be 2%. So 20% will be there, not the 2%. So 20% will be there, and horizontal flip equal to 2. That means if the values will be not, if the values will be false, we have to optimize. We have to calculate the horizontal flip as a true value. That means it can be rotated. Similarly, for test data generator, we have to use the image data generator is scale equal to 1 divided by 255. And after that, we have to use the training set, that is train datagen dot flow from directory. So this is our whole path name, and the target size will be 64,64, and the batch size will be 32. That means within the batch of 32, we will have to use the train set to validate our model, to generate our model. So this is called the batch size, and class mode equal to binary. So binary, why binary? Because we know that it can be as a either dog or the cat. So that is why the class mode will be binary. You can see the output will be as a found 8000 images belonging to two classes, and for test set you can see the 2000 images belonging to the two classes. So this is the thing about the images. You can see for the test set the similar things will have come. That is, this is the path, this is the target size, batch size, and the class mode will be should be binary. So we have trained the value, that is the training set. We have separated the value, that is training set, that is that, and the another thing, that is the test set. Now, last but not the least, we have to train our value. So how to train the values? You can see we have written classifier.fit generator, classifier.fit generator training set. So you have to use the training set to generate our model. So training set will be there. Samples per epoch, that is 8000. We have to use 8000 epochs per sample to visible the, so that's why this is a huge, and number of epochs will be 25 each, and for each and every value, and validation data will be the test set. So we have to validate our data to the test set, so that we have written validation data equal to test set. And for number of variable samples, that is the 2000, we know about the test set. So you can see within the TensorFlow backend, it is going to the epoch. And as we have written here, you can see the matrix equal to accuracy. So it will be giving us the accuracy value. So this is the epoch one. This is the epoch number one within 25 epochs. So this is the first epoch, and you can see 250 values will be 250 value each and every round. 250 values will be there. So you can see the this is the loss function, that is the cross binary cross entropy, and variable accuracy will be the zero point 0.7. That means 70% will be accuracy there, and it will take the value of 1410 seconds for the six steps. Okay, similarly, this is the 2 divided, that means 2 by 25, that means second epoch is running on, and you can see the accuracy value is down, that is 67%. For the next epoch, you can see the accuracy value will be 74%. Similarly, after taking part of the each and every value, that is after 19 values, 19 epochs, you can see the accuracy is quite high, that is 80%. And after validate our epoch 25, it is completed at 25 epochs, and you can see the accuracy, the values accuracy will be quite high, that is 81%, and you can see the loss will be minimized, that is 54%. Loss will be 54%, and you can see the main accuracy will be, this is the variable accuracy, and this is the main accuracy will be the 88% accuracy. It is touching. You can see first it has touched the value of the 58%, and after that it will be increasing, and lastly it has touched the fit of 88% accuracy. So that means, so what will be the value of the 88% accuracy? 88% accuracy means within 100 observations. If will if we will go through 100 observations, 88% cases, for the 88% cases, the model will uh, generate the true value. That means generate the actual value. So that is called the accuracy of the 88% here. So that is how the accuracy can be increased. Now let's check another thing. So this is our accuracy. That means our satisfied. We have satisfied our accuracy. But what about the model validation? That means if the values, if the values of the, if I'll give us another output to our model. So does our model can predict the actual value? That means if we'll give us a value of dog or image of the dog, if it is it predicted, will it predict the value that is this is the dog, or otherwise it will or otherwise for the images of the cat, will it be get calculated as this is the value of the cat? So now let's check, so how to calculate this value. And we know about the test data, that is the test dog. We have used an image that is the dog, that is called the test dog. Now let's check. So is so you can see we have created an function, that is the predict image, our function name. This is our function path. So this is called the function path, and you can see the function name, will be the test dog. Now you can see after that we have to use the value, we have to use the object or our model, that is the classifier. After that, we have to use the predict function, not the predict function. This is the predict variable. Image dot load images. So what will be our load images? Again, the uh, root path of the folder or the file, and the test size should be 64, 64. We know about that. Predicted modified, that is image to array, that is prediction. And predict modified divided by 255, we know about that because 255 will be our highest color. And np, that means numpy dot expand dimensions predicted modified x is equal to 0. That means we have to use the true value, so that's why x is equal to 0. And the result should be the result equal to, this is our variable result, equal to classified dot predict predicted predict modified. So this predict modified, that means this variable, we have used this variable to predict the predictive value from the classifier. Now we have written, there will be another thing we know about that. This is, if the value of the output is greater than zero point 0.5, that means if the result of 0 0, that means if this value we have converted to this array, so result 0 0 greater than equal to zero point 0.5, that means 50%, prediction will be dog. We have written prediction should be dog. And probability, what will be our probability? The resultant, that is our probability. And print, and we know about, if this is the value gets actual value of the, this is the dog, if it is predicted the value greater than zero point 0.5, or it should be the value of the dog, and we have to print it out, that is probability equal to plus of string probability. We know about this probability can be treated as a string, so that's why we have converted to this string. And what will be our prediction? That is prediction will be our prediction, that is our prediction will be dog. So that's why we have written prediction. So this is the uh, string value. So this is the if, and this is the else. So else part will be prediction equal to cat, and probability should be 1 minus q. We know about from the probabilistic manner, that is 1 minus result of 0 0, and after that we have to print the probability as well as the prediction. So you can see, so we have written this image path, and you can see the probability should be 83. That means 83% probability to predicted the value as a dog. So prediction will be dog. So it will go into this if loop, and it will simply calculate the value. You can see this is the zero point 0.8. That means this is the greater than thing. So it will be predicted as a value of dog, and lastly it will give us the prediction, that is prediction equal to prediction, that is the dog, and predict probability will be 0.83. So our model is quite satisfied and it has calculated the value as a very uh, conscious thing. That is, this is the image of the dog. So that is how we can predict an image. We can predict an image for that. Uh, we can predict an image for the convolutional neural network. So that is how a convolutional neural network or the deep learning thing can be done in our real life. So that is how you can recognize not only the cats and dogs. You can classify also any other object, any other object. But first of all, you have to use the whole data. You have to use the very prominent data to recognize the values. Okay, so that is how it can be. That is how it can. That is how a CNN can be offered. So this is the convolutional neural network. So that is how you can uh, classify an image between a dog and a cat. That is how an image can be classified between a dog and a cat. So this is all about the thing about the classification of cats and dogs, and this is the main thing, main part. That is the main part of the deep learning, and you can see all the things about the. You can also use it in the not only the machine learning. You can also use it in the AI, that is artificial intelligence. You can also use. So okay, that is the thing. Rest are the all the things. So that is how you can predict the values about the dog or the cat. So you can see we have already recognized this is the dog and this is the cat. So this is our main purpose for today's session. For today's session, this is the main purpose. So how to calculate the value, calculate or how to classify the value of the dog and the cat. So this is the thing. And thank you everyone for listening. And I'm ending the session. Thank you.